Hello guys, welcome to session number 14 of our KCET 2023 revision series. Today's topic will be oscillations, and as you can see in the brackets it's 0.86, which means approximately one question has come every year, and there have been years where there have been no questions from this chapter. So if you check it in the NCRT, it seems to be quite a lengthy chapter, but I have only use those points from the book where I've seen questions in the past. So yeah, you can just watch the orientation session on how to deal with these lectures. You can just check the playlist link and stuff. So I'll be continuing with the topic. As you can see, the first one would be basic term. The first topic would be basic terms. So I expect you to know these terms, and if you don't, you can just check the NCRT. These are most of these have been done in your class 10th or 9th. So yeah, that's why I'm going to be just highlighting them. One would be periodic motion, and the next one would be oscillation, like the definition basically, the periodic motion, oscillation, vibrations, and then what a period is, or what frequency, what's the meaning of frequency, and then displacement of a particle and the terms related to it. And the same way we got forced oscillations. I've written it over here. It's quite small, but I'm pretty sure you can still read it. So forced oscillation, and the same way resonance. So you need to know all of these terms. It's there even in the NCRT. You can just read it once. And there are a few basic formulae in the same way. Like for example, you have already done this maybe even in, let's say, class 8, or I'm not sure, this one, where over here this symbol is equal to 1 by t, where this is going to be frequency. Like this is going to be frequency. I'll just write f once again, but typically frequency denoted with this symbol. So yeah, that's why I've just written it over here. Frequency is equal to 1 by time period. So that's the formula. That's how you have to say it. Frequency is equal to 1 by time period. So the same way there are other formulae over here, as you can see, where over here w is basically omega over here. Omega is equal to 2 pi frequency. Or you can also write it as omega is equal to 2 pi by t, where t is the time period. I've used this formula. This is going to be quite useful. You'll be seeing it, so keep it in your mind. Yeah. So next one will be SHM, simple harmonic motion. So let's take this example of a pendulum. As you can see, there is this pendulum from, like, if you just give it some force, it will move from this position. This is called as the mean position. It will move to this position, and then from there again it will come back to the mean position, and then again it will go to this extremity, and then it will come back to the mean position. You would have done a lot of like a part of this at least in your grade 10 or grade 9. Yeah. So what's more important is, as you can see, there is this small picture of the positions. So at t is equal to 0, the bob is over here, and then at t is equal to t by 4, the bob would have already moved from here. Yeah, I think what it means is basically, as you can see, the time period is t by 4, t by 2, and then 3t by 4, and then t and 5t by 4. So till, like, from this to this is the only thing that you have to see for one to and fro motion. This diagram represents only from here to here. So yeah, what you have to know is when the bob is at this position, like as you can see at O, right, that time v is maximum. So you have to keep a note of that. V is equal to maximum and A is equal to 0, which means acceleration is equal to 0 and V is equal to maximum at position O. The same way when it reaches position minus A, or when it reaches plus A, this position basically minus A or plus A, that time A is going to be maximum, which means acceleration is going to be maximum, but velocity is going to be 0. You have to keep this in mind because there is this topic called energy, under which you'll be like all of this will be done, which this will be used actually. So that's about the motion, where it shows from here to here and then it moves till here. It's basically the representation of this over here in terms of the position, and I've just written at what point acceleration is maximum and at what point acceleration is 0. It's the same way with velocity. And there are a lot of formulae where you have to, like, I've just written it in SHM. You can obviously learn them. I've written all of them. So as you can see, this is the differential equation, which is given in the NCRT also, I think. So d square x by dt square plus k by m times x is equal to 0. So this is the differential equation. And over here f is equal to minus kx, as f is directly proportional to x. And the same way we got x is equal to a sine omega t plus phi. And this is like going to be one formula. And the same way we got the formula for t, which is time period, which is equal to 2 pi under root m by k. So if you're wondering how, as you can see, I've written omega square is equal to k by m. This is the formula that you have to know. Like, this is one formula that you have to know. Omega square is equal to k by m, which means when you use, like, when you can also write this as omega is equal to under root k by m. So I already mentioned that the formula omega is equal to, I think I've written it over here also, right over here. Omega is equal to 2 pi by time period. So here when you replace this t, when you write it in terms of t, it will become time period is equal to 2 pi by omega, and over here omega is equal to k under root k by m. So when you substitute it, you'll be getting this formula. This formula is very important, 2 pi times under root m by k. And yeah, I've also put this, taken this table from NCRT where it talks about all the terms. So please do note it down. I'll just put a tick. What x bracket t means, what a means, what omega means, what omega t plus phi means, what phi means, all of the terms. And as you can see, phi is basically like a phase constant. And let's say this is going to be the typical path. If it has been displaced by a certain, so if it has been displaced by a certain phase, the phase over here is written as minus pi by 4. That's the phase in which it has been displaced by. This displacement versus time. So I've just put the graph taken the graph from NCRT. So obviously, and there's another formula over here, by the way. I'll be talking about this formula once I do this part. So as you can see over here, it says velocity bracket time is equal to a omega, which means velocity in terms like with the as a function of time, velocity as a function of time is equal to a omega cos omega t. So if you're wondering where this formula came from, you can differentiate displacement to get velocity from kinematics. So when you differentiate this and keeping phi as 0, it will become a sine omega t. So when you differentiate it, it will become a omega cos omega t. So when you differentiate velocity, you'll get acceleration. So when you differentiate it again, you'll be getting a as a function of time, which is minus a omega square sine omega t. Now velocity as a function of x, if you want the formula, then this is the formula. It is going to be omega under root a square minus x square. And acceleration as a function of x, if you want, then it will become minus omega square x. And when is it maximum? It's maximum when x is equal to a, which means it is at the amplitude, like the last point, the extremity, one of the extremity. And when is it minimum? When it's x is equal to 0, which means when it's in the mean position. So this is obviously something that you would have already known. And the same way here, f is equal to m bracket minus omega square x. So if you're wondering where this came from, we know force is equal to mass times acceleration. We have just put acceleration over here. So that will become force as a function of x formula. Now we can come to this formula, a is equal to minus k by mx. So if you're wondering how this formula came into existence, then I already mentioned a is equal to minus omega square x. We already know omega square is equal to k by m. So when we put it, we'll be getting this formula. Now let's go to a type of problem. So we have in NCRT where it's written SHM as circular motion. It's an approach to circular motion, by the way. It's not like a separate topic, it's an approach. So based on it, they've given a question. I would recommend you to solve it. It's there in the NCRT example 14.4. This is the example. So you can just check the solution. It's fairly simple once you have done the above, like once you just listen to the above part of the lecture. Next one would be energy. So kinetic energy formula, as you can see, would be half m omega square bracket a square minus x square. And potential energy formula would be half m omega square x square. And we know total energy is equal to kinetic energy plus potential energy. So when you add them up, you'll be getting this. What's more important is the graph of energy versus x. So here, as you can see, I've already mentioned that at the mean position, acceleration, like if you remember at the top, I written that at the mean position, acceleration is equal to 0. So that means, or here the like you will, it means kinetic, like if you see here in the graph, this is k as a function of x. So I have already told you that at the extremity, like at one either of minus a or plus a, v will be equal to 0. So what does v equal to 0 mean? It means kinetic energy is equal to 0. So at plus a and minus a, as v is equal to 0, kinetic energy is also equal to 0, which means u will be maximum to conserve the total energy. If k is 0, then potential energy. So this line over here is called total energy. That's why it's written k as a function of x plus u as a function of x. We have already written over here total energy. So this is going to be the total energy. The line over here is going to be total energy. You can just note that down. And I already told you why it's 0 here in the graph. K is 0 at minus a and plus a. It's because velocity is equal to 0 at those points, as mentioned above. Next part would be time periods. Time periods is very important. So yeah, I'll be for simple pendulum. You know the time period. It's time period is equal to 2 pi bracket under root L. Why is it converting into shape? It's t is equal to 2 pi under root L by g, where L is the length of the string and g is acceleration due to gravity. So that was for case A. Case B, it will be spring pendulum, under which first case is when a spring pendulum is like this, where spring constant is equal to k and mass is m. In this case, it will be time period is equal to 2 pi under root m by k. It's just like how I mentioned above. It's a similar formula. So for the next part, where it is under spring pendulum, case number 2, we'll be going into cases where it's like either the springs are in parallel. This is called parallel, by the way. If the springs are connected like this, it's called parallel. Basically, when the springs are not touching each other. Whereas this is called as series. As you can see, this is spring number 1 and this is spring number 2. They're touching each other, like they are connected. And let's say that the spring constant of spring number 1 is k1 and spring constant of spring number 2 is k2 and mass is m. In this case, we have to write time period is equal to 2 pi under root m by k effective. It's just like the above formula, but over here k is replaced by k effective. And what is k effective? If it is connected in this fashion, which like I mentioned above is series, then this will be the formula for k effective. It's like the resistance formula for parallel. If you have done it, you would have done it even in 10th, I think so. And if they are connected in parallel, then it will be like how it is the series formula for resistance, where k1 plus k2 is equal to k effective. You have to just substitute that in this formula to get time period. So the same way, there is also another time period formula for tunnel SHM of an object when there is tunnel through the earth, where t is equal to 2 pi r by g under root r by g, where r is radius of earth. There are many formulae, like for example, an object in kept like moving in to and from motion in, let's say, a bucket of water and so on. But that's mostly for JEE mains. I've just written the few important ones. However, I've taken this from EduNity channel on how to calculate time period when it is like given in any case. So you have to solve sums to understand, but anyways the steps are written. Give linear displacement of x from mean position. That's step number 1. Step number 2 will be find linear acceleration. F is equal to ma, and then you will get this a is equal to minus some constant times x, and then you can replace, you have to just basically take this as omega square and you have to replace it in t is equal to t pi by omega, and that you have to replace with omega. So you can solve sums to understand it. Typically they won't ask any other question other than the 3 cases which I've mentioned, but you never know what will happen. It's always better to be on the safer side. So next one will be a type of problem. So as I've mentioned above, I think in the case number 1, which was for, if I'm not wrong, okay, I think it was, yeah, case number 1 under spring pendulum. Basically for this case, in that case, t will be the same, which is equal to 2 pi under root m by k, as long as the external force is constant. So if you're wondering what this means, sometimes they might give the same setup when this is basically kept on an inclined plane, and if they ask you what the time period is, you have to note the time period will be the same, because on the block there will be mg sine theta acting downwards, which is a constant force. So as I've written over here, as long as force is constant, external force, even the time period will be the same. That's a point that you have to keep in your mind. Next topic, which is damped oscillation, is usually not done because they won't ask questions, but I have included because it's there in the NCRT. I once again give credit to EduNity's channel for writing it in a very brief manner. I've taken it from his channel. So you can just read, give the damped oscillation and read in the NCRT. It looks something like this. It's basically when there is a medium. It depends on the medium, and that medium will be giving you B, which is the damping constant. In this case, A as a function of time will be equal to A naught, which is the original amplitude at the beginning, times e to the power minus b t by 2m, where b over here is damping constant as it's written. It depends on the medium. And the same way over here, if you see y is equal to, this is once again taken from Edunity's channel. So y is equal to A as a function of time cos omega dash t plus phi. It's the same formula as above, but you have to replace this with this, as you can see. It's basically the one which I just mentioned, where b is the damping constant, and you have to replace omega dash with this. So it will be the same, like it'll be, everything will be the same, but as it's getting damped, there are new terms that you have to include. Instead of omega being under root k by m, it's becoming under root k by m minus b square by 4m square, where b is again damping constant. So it depends on the medium. So this is the important part from damped oscillations part of it. And yeah, with this we have covered the chapter, almost all of it. Next topic would be waves, with which I'll be covering class 11. All of the topics will be done. Please do like this video and subscribe to the channel, and also share it with your friends. It will benefit the community as a whole. Keep working hard. All the best, and I'll be seeing you.